Alright, so in this tutorial video we're going to go over the last 3 toolpaths that we did, and we're going to do something a little bit different. We're not going to draw our part. I uploaded a file for download and we're going to program off of that. This is going to be a step file. It's going to be in the description. So we can go ahead and click open, or open folder. And then I'm going to navigate to where I have this file located, which is my desktop, tutorial videos, oops, solid models folder, there we go. And this one is going to be part 3, rev 1, version 1, and it's a step file. So now we have this step file, solid model in MasterCAM that we're going to program. So first thing we need to do is orientate this to our work coordinate system. There are ways to generate a custom work coordinate system, but for this we're just going to go ahead and move this to our top WCS. So I'm going to go to transform, I'm going to click dynamic, and I'm going to select our solid model. I'm just going to snap it onto anything here. And one thing I want to figure out is the distance from the top of our part to our work coordinate system. So we just need to move the Z down by 3/4 of an inch, and you could do that by selecting the shaft of our Z and dragging it down, and once you start typing it'll let you just type in whatever number you need to type in. So -0.75, enter, and I'm going to select OK. So now our work coordinate system is off the top of our part and it's orientated correctly as well. So if we click top, we can see it's going to be the upper left hand corner of this part. So let's go ahead and go to our machine. Let's go to mill, let's select default, and then we're going to expand the properties over here and select stock setup. And for stock setup I'm going to select add bounding box, and then I'm going to select this manual, select the arrow, select our part geometry, our solid model, and then it auto-populated our dimensions here. So I'm going to add 100 thou to all of these. In MasterCAM you can do simple arithmetic in this, so you could go plus 0.1, and then for Z I'm going to add 1/8 of an inch. And if we go to our front view, we can see that we have some stock on the top, stock on the sides, and stock on that other side. Should be about 50 thou all around. And I'm going to click OK. And I'm going to click OK. So we're going to do a brief overview of the face toolpath here. It's pretty simple to do. So we'll go ahead and select our face. We're not going to select anything. It's going to go off of our stock that we had set up. I'm going to go to tool. I'm going to create a tool. I'm going to select a face mill. And I'm going to do 2.9 by 3. And this will be a 3-inch face. I'm going to select finish on that. And then for our spindle speed, I'll go 5 grand, and we'll go at a 40 for feed rate. So down in the cut parameters, I'm going to select zigzag. Over here, a cross overlap, 25% is fine. A long overlap, we could tidy that up a bit. I'll do 55%. approach distance, I'll do 55%, and exit distance, I'll do 55%, and that is just so it plunges into no material and exits in no material. And for a step over, 75% is going to be perfect for this. And then stock to leave on floors, we'll just leave that at 0. Depth cuts, that's not going to be necessary. We're not taking a whole lot off. And in our linking parameters, I'm going to set all of these to absolute. I'm going to set our feed plane to 0.100. Our top of stock is actually a 1/16 of an inch on top of our actual part. So in the machine, you'll have to adjust your work coordinate system. You'll have to drop your Z down by a 1/16 of an inch, and then you'll also have to move your X and Y over 50 thou. So plus 50 thou on X and then negative 50 thou on Y. And that's just to make sure that our part is going to be center of the stock. So top of stock, I'm actually going to leave that at 0. And then for depth, we're just going to select the top here. And I'm going to click apply. And then I'm going to select OK. So we can see our simple face mill toolpath. It's going to come down, skim the top, cross, come back over and skim the top. And that's usually how I do almost all my face mills. It's pretty easy. Not a whole lot to go over right there. So in previous tutorials, we went over dynamic mill. And now I'm going to show you how you could apply a 2D dynamic mill on your 3D geometry. So over here, I'm going to select stay inside and then containment regions. I'm going to have it highlight our inside pocket profile here. I'm going to select OK on that. I'm going to select OK. And then for our tool, I'm going to right click. I'm going to create another tool. I'm going to do a flat end mill. I'm going to do 1/2 inch. Select finish. And I'm going to go 10 grand. I'm going to go 90 for the feed rate and plunge rate. I'm going to do 90 as well. We're going to do a helix in. Cut parameters, we're going to do climb. And we're going to leave all these to the default populate. And then stock to leave on floors, we're going to go 0. We're going to go down all the way to the floor of our pocket. And step over distance, I'm going to go ahead and set it at 50%. And micro lift, it may not even do that, but we'll go ahead and leave it as is. So we'll go ahead and go over to our linking parameters, and our retract is at 1/4 of an inch. That's fine. Feed plane is 100. That's going to be fine. Top stock 0, and for depth is incremental. So what it's suggesting is that it's 0 from the chain that we selected on the bottom of that pocket. So that's fine. And then entry motion is we're going to do a helix. And our helix radius, we could just go ahead and leave it at 200. Z clearance, so it's going to start its entry motion 1/8 of an inch above the part. And for entry pitch, I'm just going to set that to 50 thou. And I'm going to click apply. And I'm going to select OK. Oh, I didn't quite get our depth there. I'm just going to set that to absolute and then select depth to the bottom pocket there. So you see that we have 3/4. Okay. So we could see that it helixes in, and then it's going to work its way in and out to rough out that pocket. And then I'm going to select another dynamic mill. And same thing, we're going to stay inside and containment region. We're going to select the inside pocket of the inside pocket. All right. We'll select OK on that. We'll select OK. Tool, same thing. 1/2 inch end mill. And we're going to do 10 grand at 90 and 90. So all this is going to be the same information as we left on the last one that we did. Depth cuts, we don't need that. It's not going that deep. And then for linking parameters, for depth, I'm going to select the bottom of our part here, which is 7/8 top of stock. So we're going to go and we're going to select the top of our pocket. Now that all of the material is removed down to the floor here, and then we go down from there, if that makes sense. And incremental, so 100 above our pocket right here. And then entry motion, we do have 1/8 of an inch. However, this 1/8 of an inch is going to start off the top of this pocket. Okay. I'm going to click apply and I'm going to click OK. So if you want to see what our toolpath is going to do, the last one that we did, I'm going to click the back plot button and see it's going to drop down into the middle of the big pocket that we did, and then it's going to do its helix down. All right, perfect. So we're pretty much almost done with this part already. And now we could do our contours. One thing I forgot to mention is when you get solid models like this, it's good to check the tight radiuses on the inside corners, see what tool we can get away with. So if I go to Analyze Entity and I select that arc, it's going to give us this dialog box and it's going to tell us our radius is 3/16. So we can use a 3/8 end mill. I'm going to click OK on that. So now we can select all the surfaces that we need to clean up. Well, the contours we need to clean up. I'll select this one. Notice it's heading in the wrong direction. I'm going to flip that. So that's going to be our outside profile. And then our inside profile, we're just going to select the same contours as we did for the 2D dynamic mill. And this direction is correct on the, so OD clockwise, ID counterclockwise, right? Okay. And I'm going to select this. So we have 3 different chains and 2 different depths. So let's create a tool. Let's create a flat end mill, and we're going to do a 3/8 to accommodate the 3/16 radiuses, or radii. I'm not sure how you say it. So 10 grand on the spindle, 90 for the feed rate, and plunge rate. We're not going to be plunging into any material. Cut parameters, I'm going to turn on where. We're doing a 2D contour type, and the rest of these are good. For our lead in, lead out, I'm going to tidy this up a bit. I'm going to do 25%, 25% on the length and radius. And I'm going to transfer that over to our exit. And then I'm going to do an overlap of 100 thou. And linking parameters. So depth is 0 to incremental. Top of stock, we could leave that at 0. And feed plane, do that 100 above. Actually, I'll do incremental on top stock. Let's see what happens with that. I'm going to click apply. And sorry, for clearance, we need to do absolute and put it at 100. Just so when it jumps from contour to contour, it's not going to go through any material. All right. So let's hide all of these by selecting our toolpath group 1. I'm going to hide all the toolpaths, and then I'm just going to turn on the contour to see what happens. And we could see what it's going to do. yellow toolpaths are your rapids, and then green, red is your entry exit, and blue is the actual cutting. So now if I click back plot, you're going to see it's going to come down onto that corner. It's going to go around the part, bleed out, it's going to jump over, then go into our inside pocket, clean up that wall, and then it's going to clean up the inside pocket or the inside pocket, right? Alright, our part's almost done. Next thing we need to do is just drill these through holes. We could turn these into taps if you like, but in this tutorial I'm just going to go ahead and just drill them out. So again, we could go to Analyze Entity and see what size holes these are. And 187. That's our 3/16. So let's go ahead and go to our toolpath and we're going to drill. And I'm going to select. You can select the top contour of your hole, or you could select the face of your hole. It will generate it the same. I'm going to create a tool. I'm going to go to my drill here, and I'm going to just type in the dimension that we need. 0.187. Finish. And for this, I'm going to go 3 grand at 30. Cut parameters. I'm going to do a peck drill of 100 thou increments. And for linking parameters, I'm going to put absolute. So it has our depth right there. Perfect. Top stock. Retract. Leave that absolute at 0.1. I do plan on doing a video on how to program drill paths on multiple different depths, so it's not always going to peck in the air, but on this one all our holes are on the top, so that'll be fine. And tip comp, we'll turn our tip comp on. If we're using a 118 degree drill, it gives us our punch through depth right there, our tip length. So I'm going to click apply, I'm going to click OK, and we could see that we pretty much have our part programmed. The only other thing that you'd probably want to do if you're going to machine something is chamfer milling to edge break, and we'll go over that in a little bit too. So if we go into verify, we could see what we have so far. So we plane the top. We're doing our dynamic mill. It's cleaning that big inside pocket, then it's going to helix down into a smaller pocket. It did our contours and it drilled through. But you can't see, we just left material on the bottom, you know, just for something to clamp onto. So the other thing that we can do is our model chamfer. It's comparable to our, so remember in the contour tutorial where we did the 2D chamfer mill. If we do this, we're also going to be able to do select the edges that we want to break for our. So I want that edge broken, I want that edge broken, and I want that edge broken. So for tool, let's create a chamfer mill. Let's use a 3/8 chamfer mill. Oops, 375. Perfect. And 45 degree. And for our tip, you have to figure out what kind of tip you have on your chamfer mill, but let's go ahead and leave it at 1/16 of an inch. And I'm going to click OK. I'm going to spin this at 6,000, 60 IPM, plunge rate 25. That's all good. And for this, I'll do wear. So if it's if you want the chamfer bigger or back it off, you can adjust it on the machine with your tool diameter offsets. For chamfer width, let's do 20 thou, and for how low we want it to go, we could just put it in 50 thou, just so it's not plunging in too deep. Lead in, lead out, that's really not necessary. Linking parameters for clearance, let's do 100 above, retract 100 above, and feed 100 above. And I click apply, and I click OK. And we could see, sorry, let me hide our toolpaths, and then I'm going to do model chamfer. So notice it did our inside pocket and the inside pocket, but it didn't do our outside pocket. So let's see if we could just go ahead and go into our geometry and then add that. So we don't have an add, but it does have, okay. I see that it does have that, but it chose not to generate the toolpath for that. And I'm not exactly sure why that is. But anywho, we could just do another model chamfer and keep all the settings the same. But in geometry chain, we just select the outside. So it's going to do the inside pockets and then do the outside. All right. So now if we go into verify, we should see all that, including our deburring edge break. And we can see we have our edge break on the inside and outside. It's in performance mode, so it's kind of generating our chamfers. Kind of crappy, but that's an idea of how to program a part like this. And as we progress through MasterCAM and we go over into our more of these toolpaths, we should be able to cover everything. And I'm going to start supplying solid models. At work, I generally don't have to draw my parts. It comes down from the engineering team, where we get solid models from the customer that we can just program off of. And that should be able to get you used to what the work environment would be like. I mean, there are occasions where I do have to draw, but most of the time I just get a solid model. All right. Thanks for watching, and be sure to look out for another video. All right. Bye.